Hey everyone, myself Bhavya Goyal, a student at IIT Gandhinagar. I welcome you at CodeChef and let's have a look at this question. So today's question is deleting substrings. In this question, we are given two strings s and t of size n and m respectively. Now in one operation, we can choose some substring of s and delete it and concatenate the strings formed. And we can perform this operation multiple times if needed. So let's say we are given a string as something like A, B, A, C, D, E. We can choose some random substring, like let us say we choose this substring and remove this substring from the string S and, and concatenate the remaining string. And this would be considered as one operation. Now we need to tell if it is possible to transform the string S into the string T. And if it is possible, what is the minimum number of operations required? Now let us once see the test input and then let us see the constraints. So in the first input, we are given A, B, C, and the second string is AC. So we can remove this B and we'll have AC, and it requires one operation to make them equal. In the second test case, you can just try it out that there exists no set of operations in which it is possible to make the string S equal to string T, hence the answer is -1. In the third test case, they are already equal, so the answer is 0. In the fourth test case, we can delete this substring, which requires one operation, and then S and T are equal. So the answer is 1. In the last test case, we can remove this A, and this A to make both the strings equal, which would require three operations because we need to remove three different substrings. Hence, the answer is 3. Now, let us once quickly see the constraints. So, in the constraints, the number of test cases is in between 1 and 10 is by 4. N is in between 2 into 10 is to the power 5. And here is the interesting thing. M is in between 1 and minimum of n comma 100. So m's maximum value is going to be equal to 100. So a solution of the order n into m would work in this case, which hints us that dp might be used in the question. And SNT are both lowercase Latin characters only, and the sum of n do not exceed 2 into 10 is by 5 over all the test cases. Now let us once see the solution. So as I discussed, n is less than or equal to 2 into 10 is by 5 and m is less than or equal to n comma 100. So can we think of using dp in this? Let's figure it out. So let us say this is our string s and this is our string t. So we are initially on these two characters, right? And we are trying to make both the strings equal, right? So for this character on the string s, we have two options. Either like try to match these two characters if it is possible. Otherwise, just delete it, right? So let's say we delete this. Let's say we delete this as well. Let us say we deleted this, and this as well. Now we are over here. So we have an option to match these two characters, right? So if we match them, then okay, we can just try out to match these two characters. Like we have again two options for this. We can either match these two characters or we can like simply delete this character, right? So let us say we match these characters as well. Now we need to match, like we have again two options, either to match these two characters or delete it. So let us say we match them as well. Now we need to just delete this character because this T and this F are not equal. So let us say we delete this. Now we need to delete this as well. Now let us try to match them up. So we'll be over here and then we can match these two as well and we'll be done with the strings, right? So we required two subarrays to delete all the, like to make both the strings equal, right? So this gives us some hint that, okay, we can use two pointers, I comma j, which represents the current element we are on the string s and t. And then we have two options for each character, either delete it or just match those two characters, right? But how would we count the number of subarrays using it? So over here, if you notice, we can either continue our delete operation or we can continue our match operation. So if at every point, the first occurrence when we started deleting, we add a 1, then we can count the number of subarrays, right? So what I mean by this is, let us say we are starting with this index, right? And over here we are at this index. So until now we were trying to match these empty strings, which were matching. And now this is the first occurrence where we started deleting it. So we'll add a 1 over here and we'll say that we're deleting. Then we're still deleting. And then we started matching them, right? So there's just one occurrence where we started deleting. Now over at this index, we again started deleting, right? So the previous operation was matching, but at this operation, we started deleting. So we'll add a 1 again. We deleted again, and then we started matching. So in this way, we can count the number of subarrays that we deleted, right? So this gives us some hint on how we can use DP, right? Now let's try to formalize it. So we have two options for every character, right? So in our string S, either start deleting this character, in which case we'll be adding a 1, or if previously we were deleting, then continue deleting this character. So we'll delete this character in both these cases. But the only difference is we'll be adding a cost of 1 because we just started deleting this. And the other option is we keep matching this character with the string t. Right. So can we define our DP array as, or the recursive function as f of I, j previous as the minimum number of deletions required starting from the index I in the string s and the index j in string t such that the previous operation was equal to this prev, where prev is equal to 0 if the previous operation was matching, and prev is equal to 1 if the previous operation was a deletion operation. So how would the transitions look like? So if S of I is equal to T of J, then this is one possibility that we match these characters. So we'll ask our recursive function that what is the minimum operations required, starting from I plus 1, comma j plus 1, and my previous operation, like this operation was equal to a 0, which means a matching operation. And the other possibility is that we delete this character, in which case we'll ask our recursive function to tell us that what are the minimum operations required, starting from I plus 1 because we deleted the character I, and j in the string t because this character is still not matched, and the previous operation was a deletion operation, and we'll add a 1 if the previous was equal to a 0. So if the previous was 0, that means we are just starting the deletion. That means like this is just the starting of the deletion of the subarray. So we'll add a 1 denoting that we are starting to delete a new subarray. And what would be the base case in this? So if I becomes equal to n and j becomes equal to m, we'll simply return 0 because both strings are empty. So we just need 0 number of operations to match them. And if I is equal to n, but j is not equal to m, this means that our string s is empty, but we still need to make some deletions in this string s to make it equal to the string t, which is not possible, right? Because we cannot make any deletions into an empty string to make it equal to some non-empty string, right? Hence the answer is, and hence we'll return infinity in this case. And that's pretty much the whole solution as well. Let's also discuss the time complexity ones. So n is less than or equal to 10 raised to the power 5, m is less than or equal to 100. And over here, what are the total number of states that we would have? So this I could have a maximum value of n, this j could have a maximum value of m, and this previous would be 0 or 1. So the maximum number of states that we can have would be n into m into 2, right? And how much time is it taking to calculate one state? 2 time, right? Like either this or this. So 2 into nm, which is 4 nm, which would be 8 into 10 raised to the power 7, right? Because this is 10 plus 5, 2 into 10 raised to the power 5, and this is 10 square. And hence this would be the total number of like operations we'll be doing approximately, which would easily pass the given constraints, right? And that's pretty much the whole solution as well. Now let us once look at the solution in C++ and Python. So we'll run a loop or call this function solve for each test case. This will be taking in the input of n and m, and we'll be resetting the DP array to -1. We'll be taking in the input of the strings. We'll define our answer as sol of 0, 0, 0. Like we'll call this function, and if this is infinity, that means there is no possible way to make them equal. So we'll print -1. Otherwise, we'll be printing the answer. Now this is our base case. So if I is equal to n and j is equal to n, will return a 0. Or if I is equal to n, will return infinity. This is our memoization step. So if this state is already calculated, just return it straight away. And over here, just calculate the state. Now we have two possibilities, match this character if they are same. So if they are same and both I and j are in the bounds, we'll return the answer to be min of answer, comma. So all of I plus 1, j plus 1, and we'll say that the previous operation was a matching operation. Or the second possibility is to delete this character. So answer would be equal to min of ans comma sol of I plus 1j and a 1. So this one is denoting that the previous character was a deletion operation. And we'll be adding a 1 if the previous was 0 because we are transitioning from continuing the matching to starting a new deletion. So this would represent that we are starting the deletion of a new subarray. And yeah, that's pretty much the whole solution. The time complexity again is n into m or 4n into m. Now let us see the solution in Python. So we'll call this function for each test case. Now inside this function, we have defined n comma m. We're taking an input of s and t. We're defining the current state and the next state of our DP array. We're running a loop from n to 0 and m to 0. And this previous would be in between 0 and 1. Now these are our base cases. So if I is equal to n and j is equal to m, we'll say that DP current is equal to 0. And if I is equal to n, we'll say that DP current is equal to infinity. Otherwise, this is the match operation. So if both S of I and T of j matches, we'll say that answer is equal to min of ans comma dp next or dp previous of j plus 1 0. Otherwise, answer would be equal to min of ans comma dp next j1 plus previous of 0. This represents the deletion operation and we are adding 1 if the previous was equal to 0, which basically represents that we are starting to delete a new subarray. So this index is like at this index we are starting the deletion. So this is like the start of deletion of a new subarray. So we'll add 1 because we are deleting a new subarray. And then we'll say that dp current is equal to this answer. And then we'll simply swap these two. And in the end, our answer would be simply dp of next of 0 0 and will return or will print -1 if result is greater than or equal to infinity. Otherwise, we'll simply print the result. And that's pretty much the whole solution. The time complexity is n 4nm and the space complexity over here would be this m into 2. So we have optimized the space by using these two arrays. And yeah, that's pretty much the whole solution. I hope you liked it. Thanks. Bye.